everybody, welcome. I'm Dana Wallman, Managing Editor of Engadget, and we have a great panel set up for you today. We're going to be talking about education and technology, which is obviously a very broad topic, and in the 30 minutes allotted, we hope to talk about a bunch of things. We hope to talk about just the role of technology in the classroom, but also, more recently, the importance of teaching computer science and other technical skills to kids starting at a young age. So here we have a great collection of experts. We have Pat Young-Pradit, who is the Director of Education for Code.org. We have Jeff Branson, who is the Education Outreach Coordinator for SparkFun Electronics. And we have Rodrigo Arboleda, who is the CEO and Chairman of the One Laptop Per Child Association. Welcome, you guys.
Thank you.
Thanks for having us.
Yes, thank you.
So, just to get everyone oriented and just let everyone know what you're working on, just give us one or two sentences on yourselves and what you're working on these days.
Well, I'm the chairman of One Laptop Per Child. This is a project born at the Media Lab of MIT by my classmate and dear friend, Nicholas Negroponte. We are both architects. We started working on this type of projects 31 years ago when the beginning of the Media Lab, and we are working right now in delivering laptops with a pedagogical ecosystem that goes with them worldwide. We are in 60 countries, 21 languages, and we have delivered already 2.5 million laptops as a non-for-profit organization.
Great.
And I'm Jeff Branson. I'm with SparkFun Electronics. So SparkFun's an open source hardware and software company in Boulder, Colorado, and we do a lot of stuff around emerging technology. Right now we're involved in a national tour, about 80 stops nationally over the last 3.5 months. So we're really boots on the ground about getting hardware and programming environments into kids' hands.
And I'm Pat Young-Pradit. Hi, folks. I'm the Director of Education at Code.org. I actually taught for 12 years up to this past June, and now my mission is to bring computer science education not just to my classroom, which I did, but also to the entire nation. So every single school, every single student in the nation.
Great, and you had a video you wanted to show.
Yes, and I have a video I'd like to show. It's a 1-minute version of the 5-minute video that actually went viral over the past year. It hit #1 on YouTube for a day. That's pretty good for a computer science education video. So let's roll that video.
Here we are, 2013. We all depend on technology to communicate, to bank, and none of us know how to read and write code.
The first program I wrote asked things like, what's your favorite color? Or how old are you?
I wrote a program to play tic-tac-toe.
I first learned how to make a green circle and a red square appear on the screen.
You're just trying to make something, trying to transfer something from your mind to the computer or to a tablet. It's an experience.
The whole limit in the system is just that there just aren't enough people who are trained and have these skills today.
The programmers of tomorrow are the wizards of the future. You know, you're going to look like you have magic powers compared to everybody else.
Great coders are today's rock stars. That's it.
And I have one picture.
Great, so I'm actually really glad we started with this video because it gives us a lot of perspective. If we were having this panel 10 years ago, I'm not sure that we would be discussing the urgency of the need for children to learn coding. So that's a great place to start. Why now? Why is it especially important now for children to learn these computer science skills?
Well, perhaps I should start because not being the older one in the group, I've been at it much longer than you guys. I've been here we started in 1982 in my country of origin, Colombia, when we put together with Nicholas and the group that now become the Media Lab of MIT, the first educational at distance program using technologies of the digital age in education. So that's, from the beginning, that was our mission. And this is all a part of two persons, Jean Piaget in Switzerland in the 1950s and Seymour Papert together with him, who became later on one of the founders of the Artificial Intelligence Lab at MIT and at the Media Lab together with Nicholas. So the whole idea that we have is that children that learn how to write code from a very early age are much better prepared to tackle the challenges of the 21st century production of wealth, which is going to be focused on intellectual property, inventions, exploration, the joy of discovery, the whole idea of prolonging indefinitely in time the learning environment of the kindergarten as a mode of life, that was inspiring for us from the very beginning. And all of what we have been doing ever since is trying to start every time at an earlier age into this type of learning environment. So the idea is to learn how to learn. When the child is the one that gives the instructions to the machine, instead of the machine giving instructions to the child, the whole neurological environment of the brain changes. And the whole idea is to make the child empowered and for them to be the agents of change. That's as simple as I can put it.
Jeff and Pat, what's at stake here in terms of teaching kids computer science skills?
I'm really interested in hearing Pat's take on this.
Well, there are two reasons I give crowds about why it's important to get kids coding. Number one, economic. So the Bureau of Labor Statistics has projected STEM job growth through the decade, and 60% of STEM job growth will be in computing. And so 17 or 18% will be in engineering, 7% in life sciences, but 60% will be in computing, and yet 9 out of 10 schools, K-12 schools, don't even offer a computer science experience to their students. So that's a problem, number one. And number two, it's much more than just kids becoming computer scientists. Not all kids are going to become computer scientists. It's not about getting all kids to code. We're called code.org just because it's snappy. But it's really about getting kids to participate in the 21st century as creators of technology and creators of their future rather than passive consumers.
I was going to ask you guys this question, which is there are kids like me who are going to grow up to be journalists and writers and reporters. And what is the takeaway for kids like that, even if they don't end up pursuing a career in the sciences?
Well, I think all three of us in talking backstage agree that the new literacy is digitally based. And for us, generating content is a huge cornerstone in that rather than consuming. We are really far down the software chain in a lot of ways. And the farther up the tool chain we can place kids in educational environments, the more power they have. So it doesn't matter whether it's art or it's technology or it's shop class. What we're looking for is, particularly where I come from, is three things. And that is build a circuit, learn to write code that lives in that circuit, and then find a problem or a quality of life issue that those two things can address.
I have a question for all of you guys, and this is very personal to me. How do you get more little girls, especially, interested in the sciences and interested in computer science? How do you get them excited about it, and how do you get them to keep up with it as they get older?
Well, since we start with very young age children, nowadays with the touch screen, we are starting with ages 2.5. We are now in pre-kinder and kinder, not anymore in primary school age. Independently, if that child is going to become a dentist, a philosopher, a sociologist, or whatever, if that person learns how to write code, 4 elements of the brain becomes apparent. Number one, you have to have critical thinking. You need to know if the program worked or not. The second one is that you have to have a solution-oriented mentality. Otherwise, we throw the towel at the second type that you try to do the debugging. It's more important the debugging than the writing, as a matter of fact. The third one is the collaboration of sharing. In the past, we were very much oriented towards isolation and doing it on your own. And the final one is that when the program finally works, you have to step back one step and reflect. So those elements of the mind, independent of what you're going to do in life, being a gender or a profession oriented, are totally important that you have those elements in your mind. And writing code and debugging the code is the most important comprehensive ecosystem that you can teach about a child to learn how to learn.
I saw you shake your head really emphatically when I asked the question.
So I have, this is very personal to me. I had a Springbrook High School Women in Technology Club that grew from 10 girls to 45 girls. And so I promoted heavily to women because I understood the need to get more diverse perspectives in technology. And I also have 2 little girls. And so how do you reach out to girls? Well, it starts with, well, one piece is curriculum. And so rather than just coding at a screen, and that's computer science, folks don't understand that computer science is way more than just programming. It's abstraction, algorithms, it's the internet, it's impact, it's creativity. And so there are new courses coming out sponsored by the NSF and the College Board, Computer Science Principles, Exploring Computer Science, that are nationally recognized courses that are really going to meet it's going to meet the need to broaden participation in computer science.
I think also that we're all involved in creating new interfaces and new technology that aren't so gender biased. You know, I saw Aya up here earlier, and Little Bits is wonderful, and it's a pretty neutral platform, and the LilyPad stuff that Leah has done, and Flora from Adafruit. I mean, all these technologies now do relational storytelling. They do different biasing in terms of the way that we deliver the information and give people opportunities to interact with the hardware end of things. And I think that's super important. And digital storytelling. You know, taking that relational learning style and being able to do new forms of digital storytelling. So it's a more humanist approach to technology.
What would be an example to you of a more gender-biased technology?
Really? Okay.
I mean, yeah.
Okay. You know, the easy one for me would be first-person shooter. You know, we have so much technology that's based on that, and I know that's an easy target to hit. But are we really building platforms that apply across a diverse spectrum of appeal?
Oh,
and
so by gender biased, you mean that plays into existing stereotypes?
Exactly. Yeah,
Okay.
and I really think that we're fighting hard, I think, across the board to develop new ways to present both hardware and software to people, because the software lives on top of the hardware.
One thing that we have been working a lot for many, many years now is to use toys as a way for children to become joyfully engaged. And we have developed with the Lego group for 20 years, the Lego Logo Learning Laboratory at the Media Lab of MIT, which is using toys and the creativity that comes along with them to create robotics and to do all types of things that at the end is programming through a Trojan horse type of thing, but in a very nice and playful environment.
I'm going to ask you guys a chicken and the egg question. I remember a time when I was growing up when computer science and being into computers at all was considered a very nerdy thing, and being nerdy in general was not a good thing. Now it seems that being nerdy is cool, and knowing about technology is cool. Is that something you guys have benefited from, or do you guys take some credit for making it more accessible and cool and hip for kids?
Well, you know, it's easy for SparkFun because we kind of, you know, we create all the flashy stuff, the blinking LEDs and the robots and the things that are flying around, and so it's really easy for us to kind of tap into that. But at a base level, if you look at our corporate structure, 4 out of 7 directors in our company are women. So we're trying to steer things in this kind of new way of thinking. And it is cool to be a geek these days, but I think that's because people recognize that there's power in it, and that this distribution of wealth and power now is from an emerging technocracy in this country.
In our case, the whole idea started in 1970 when Seymour Papert arrives at MIT. Nicholas, we are both architects. Nicholas and I are architects, so you can ask what is a nice girl like me doing in a place like this type of thing. I am not in the academic of computer science fields. And Nicholas was working at the time trying to find a graphical user interface for us poor architects, the last generation of architects that were still drafting with parallel rule and triangles and pencils. And when he heard Seymour Papert talk about computers, education, children, he said, we should expand my area of endeavor not to cover only architects, but the common people. And that's how, to answer your question, how to engage so this doesn't look like a nerdy thing, that this is good for the common person. And that has been the whole idea of the Media Lab, is to make sure that digital age technologies are available to the common people.
And I just don't like the whole like cool geek, girl geek kind of, I don't want to equate geekiness and nerdiness with computer science at all. It's not a nerdy geeky thing. In fact, if we could just show a picture of my students from last year. I don't know if it's back there. Yes, so these students are, this is my dream class here, my 7th period AP Computer Science class. So AP Computer Science, this was a dream class, a class where, you know, even the jocks took computer science, and actually if you look at the first row, all the jocks actually happen to be girls. And so, you know, this is a dream class simply because it's not about kids being nerds and geeks, and whether you're a girl or a boy or black or white, you're a nerd and you're a geek and you can take computer science. It's just about everyone taking computer science because it's just cool, not just for nerds and geeks.
Want to swing back to that idea that kids should be doing this at an early age. And this seems to be a recurring theme in what we're talking about. Rodrigo, you said in conversations we've had privately that kids should be exposed to computers and tablets and electronics, period, from an early age. And I hear you guys saying that kids should be learning computer science skills and these critical thinking skills from an early age. What's at stake there? Can we talk about sort of this possible digital gap and why it's so important to get invested early?
I'd take it even a step further, and I think electrical engineering at an early age. Because, again, all of this software lives on top of hardware, and we want the base access to this technology. But as a ramp, building up, I go back to Thomas Friedman. There's a kind of to paraphrase Friedman, he says, it takes about 15 years now to produce a sufficiently advanced computer scientist or engineer to work at the level of technology that's prevalent in our society. So we have to start earlier because we're getting people late. And the development cycle is lagging, and we all acknowledge that. So by starting earlier, by exposing kids to coding environments earlier, by exposing kids to circuit building earlier, and exposing them to computational thinking earlier, we're starting the learning progression that much sooner and getting more qualified, competent, innovative people out of the system sooner.
So deciding in college that you want to major in computer science is a little late.
It's about 10 years late.
10 years late. What do you think,
what
Pat?
we are seeing right now in some countries in which we are, for example, I just came back from Africa this weekend, and we have 220,000 laptops in Rwanda. And the transformation of the society that we have seen because of these children in agricultural regions and so forth have been exposed to this type of ecosystem of learning. It's not the computer or the tablet. Giving tablets or computers don't solve any problem. It's what to do with them. And once you give that child of 7 years or 8 years, and that child learns how to write the storytelling by giving the instructions to the computer rather than receiving a class passively, it makes a hell of a change. It's the whole transformation of society what is coming in there. It's really amazing to see the transformation of society. The sad part is that we are seeing that transformation in countries different than the US when we should be doing that here right now in the United States. That's what we think we need to really start doing. And what the code.org is trying to do is because we're going to have a tremendous deficit of people learning how to write code in this country if we don't shape up. That is a very complicated problem that we are facing.
Yeah, and there was a time in our country's history where to participate in technology, you had to understand how to use manual tools and big equipment. But now you just, you can pick up anything. Even you could pick up a mobile phone and learn how to control the bit, the 1 and 0. This is the information age. And that's a very simple thing for a kid as young as 4 or 5. I was just coding with my daughter. She's 6 years old. And she totally understands how to do some very simple things. We couldn't do that back in the day. Kids couldn't participate in the world of technology that way that they can do now.
I think one of the ideas that's emerging from this is that we now have these machines that learn. And what we're all talking about is living in this age where we have these kind of proxy agents for our biological beings. And how do we teach these machines, and how do we develop a system that teaches kids how to teach machines? Because that's the problem that's in front of us. With this digital revolution, we've been able to mimic human decision-making processes, and we've been able to offload some of the dull, dirty, or dangerous tasking in our lives. And the question becomes now, how do we teach people how to teach machines?
How do we teach people?
Ones and zeros.
But even if we want to go beyond ones and zeros, the big horizon ahead of us is the 4 letters of the 4 molecules of the DNA of the entire human genome. Because the zeros and ones and the gigantic computers that were needed to decipher the incredible mystery of the double helix of the human genome are opening a field in which the next 50 years are not going to be the digital age. It's going to be the biological and the genetic age. And for that, you need people to understand the zeros and ones. Otherwise, you will never get into the next step, which is the 4 letters of the 4 molecules that conform our entire human genome.
One thing I've been waiting to ask you guys is teaching kids with different levels of access. And this applies both at home and abroad. I know that, Rodrigo, you work in developing nations, and I'm sure that you guys have had some access to lower income communities in the US. It's a great start giving kids access at an early age to computers and tablets and just the internet. Is that enough, or do kids suffer if they don't have that at home also?
Yes.
In our case,
yes.
we must allow those children to take them at home because the multiplying effect is enormous. The ownership of the computer is tremendously important psychological-wise because the pride, the self-esteem, the feeling empowered. The first nights that we give those laptops to children, they sleep with them in their hands because they are the most precious possession that they ever had. So it is tremendously important for that to permeate society.
This idea now that information, a lot of us came of age where information was right only, and it didn't change. And with the internet, the nature of the information that we encounter on a daily basis is subject to revision and addition and flushing out. And I think as well as just the hardware piece, getting one laptop per child into somebody's hands, getting a laptop or tablet into somebody's hands, it's internet as well. Because this allows this constant revised stream of information to enter an individual's lives. And it's not, you know, we're not just seeing this overseas. There are a lot of rural areas of America where technology and high-speed internet is still an issue. And how do we do that? How do we push laptops and technology into schools that have no budgets for this? And this is why the movement towards libraries as maker spaces, I think, and community-based education initiatives, scaffolding from standard public education into the library system, combining budgets and efforts in order to build these community frameworks for education and access. I think that's a huge leap for us as a country.
And when I think about access, I don't think about hardware, I think about educational and curriculum access. And so I think about how do you show kids that this coding thing is not a mystery, that it's very accessible by you, a fifth grader or fourth grader, and you've never coded before, you've never played with robots before, that you can actually do this. I mean, one way to do that is obviously to first embed it into things that they already enjoy, like you know, video games, but sometimes video games only you know, really appeals to a certain subset of our population. And so it's really just about giving every single kid the opportunity to learn it within either a science or math class or just as a separate class. So that's what I think about when it comes to access.
Well, 7 years ago, we proposed at the ITU, at the International Telecommunication Union in Geneva, that at least at the school level, internet access should be a human right. And now I'm very happy to see that internet.org has been created 4 months ago, in which even went further to say that internet access should be a human right for everybody at no cost at all. It's like having a pencil or a piece of paper, because it's becoming such an important transformational element of society today that not having access to internet on a free basis is going to become a very, very difficult point in the life of a country from now on.
Particularly, you know, as we move into these Java-based apps, and so much of the software and apps that we're writing and using come up in web browsers, and the updates come up, but it's going to be, your systems won't work.
So you would agree that internet access is definitely a human right?
Let me give you an example. We have a country, which is Uruguay in Latin America, in which every child, and when I mean every child, includes autistic children, Down syndrome children, visually impaired children, or physically impaired children, in primary age school, has one of our laptops connected to the internet and with the ecosystem of learning that we have provided. When a country reaches that point of saturation, wait 10 years from now and start to see miracles happening with those children getting into the age in which they go to the job market. It is incredible. It's the most important educational laboratory in the world, that country.
How far off are we from a world where every person has internet access? It seems like a very distant, far-off world, but maybe you guys are more optimistic.
Does everybody need internet access? I mean, we're saying this, yes. We were talking backstage about making really good decisions now that are going to impact the trajectory of technology over the next 15 years. And how do we carefully make these decisions? Who gets in? I don't feel qualified to answer this question, really. You know, who gets it, who doesn't, who should have it, who doesn't. I don't feel like I want to make that decision. And I don't want to speak for anybody else, but I feel like that's a really delicate question. And we were talking about, a technocracy or digitally enabled veneer of society. Is that where we're headed? I don't know. But are there more important problems? This raises, a priorities question for me. I don't want to monopolize this.
Okay, I'll rephrase and I'll give you a smaller scale priorities question. Let's even talk about the US and the state education systems. What are the biggest things that even our state education systems can be focusing on in the next year, the next 5 years?
Here's a small thing. So so right now, I don't know on the code.org side if we've updated it, but basically it used to be 35. Now there are a number of states in our country that don't consider computer science connected to a graduation credit. So that's basically what it's saying is you can take yoga, and that counts as a PE credit, and you can take some other subjects, but you can take computer science, it just doesn't count as anything. And so first off, it's just changing state policies as to how they recognize computer science, number one. And then number two, obviously valuing the need to expose students to this type of subject by creating CS teacher certification programs. I mean, education is a beast, and there's no one silver bullet. There are multiple things that, honestly, it's not magic. It's happened with math, it's happened with science, and now it needs to happen with computer science.
We are still teaching in the same manner that 150 years ago we were teaching. When the Industrial Revolution began, people migrated from the agricultural fields to towns, and they created production lines of automobiles or many other things. They didn't know what to do with the children of those families that came along with the worker that went to the factory. So they created also a production line of a school. So if you were 5 years of age, you needed to be in first grade. If you were 6, you could not be in another place but the second grade, and so forth and so forth. Today, with the digital age technologies that we have at our disposal, we can have a personalized learning environment to be also monitored and evaluated through very difficult mechanisms that tell you that child, even if he's 5 years of age, could be more advanced than the 7 year of age, or if the 7 year of age could be doing what the 5 year of age is doing. And that's the most important change that we need to embed into this country right now. If we don't do it right now, believe me, Taiwan, South Korea, Singapore, Finland will really take the lead.
I feel like some of this is connected to the standards-based movement, I have to say that. We're held accountable for certain core competencies, but beyond that, for me, the crisis lies in how you learn to learn and giving kids opportunities that are based in a constructivist model that reverse engineer curiosity about the fields of knowledge that they're encountering, that ask them to design their own educational process and their own accountability around the standards that we're asking them to learn. Like, that's the crisis. Introducing that to school administration, to the National School Board Association, and saying, how are we going to adopt new techniques that reflect this access to technology and ideas that this generation of kids who are learning now have full grasp of, and go to school and recognize this difference between what they can get off the internet and what they get in a classroom that's being stuffed down their throats by school boards and 25-year-old curriculum. They know it's a joke.
And I think that computer science is the most onlineable, blendable subject out there because it's computer science. You're already in the environment. And so, at code.org, we're espousing a blended learning approach to computer science where kids learn through online, self-guided, self-paced tutorials, as well as these unplugged lessons where kids are learning computing concepts, but without a computer, because it's not just about a computer, it's about learning computing concepts just hands-on as well.
Great.
Yeah.
Well, we have just a few seconds left, so we're out of time. But thank you guys so much for joining. Everyone, thanks for coming.
Thank you.